Here's the chapter 1 practice test. So number 1, identify the function to which f of x is equal to 8 belongs. And remember, when it says it's just a number, no x or anything else like that, remember that is just going to be a constant function. So number 1 is constant. Okay, number 2, graph g of x is equal to x plus 2 and its parent function, then describe the transformation. So since it says it's x plus 2, remember what I suggested to you, ladies and gentlemen, that you take away any numbers and that stuff and see what happens to x. Is it in the absolute value? Is it in parentheses squared? Well, on this one right here, we have an x. So we would say our parent function is y is equal to x. Now remember, you're going to have to probably give them 2 points. So remember, if x is 0, y is 0. If x is 1, y is 1, etc., etc. Okay? So you're going to have to draw this on the thing. All right, mine isn't perfect, but again, remember, we know that. So then our next one is going to be x plus 2. So if we use y is equal to x plus 2, now remember, we talked about all the stretches, the shrinks, the reflections. On this one right here, it's on the outside, so we know it's going to be up 2, right? So we know it's, how did we go up? We went up vertically again. You're probably going to have to give me a couple of points and then draw your line. All right, so here's my y is equal to x plus 2. Here is my y equals x. And what are they asking us? So the graph of x plus 2 is and it's going to be a drop-down menu. So remember, on this one here, it's going to be, what did I do? I went up, right? I went up, so it's going to be vertical. Translation, I went up how many units? I went up 2, right? I went 2 up the graph of the parent function. Number 3, graph g of x is equal to -3 and its parent function. So remember, on this one here, it's a constant function. And remember, on our constant function, I told you we didn't use the x-axis, we used 1. So we know that we're going to, again, you'll probably have to give them a couple of points so that you can draw your line. So here's our f of x is equal to 1. That is our parent function, all right? So then our other function is going to be -3. So I'm going to go down to -3, and I'm going to draw a line there. And how far did I go down? Went 1, 2, 3, 4. So again, up and down is vertical, side to side is horizontal. So we went vertical. And translation, 4 units, and we went down of the graph of the parent function. Okay, number 4. Now we have to select one, all right? So on this one here, if we remember, these are all quadratic ones, all right? So if you have to look, now remember, on a quadratic one is y is equal to x squared. And if you recall, I did a quick one for you. I did -2, -1, 0, 1, and 2. All right? So when it was -2, -2 squared was 4. We had 1, 0, 1, and 4. So on this, remember here, I'm kind of looking at them, all right? And if I look here, and I'm just going to choose, well, this one right here looks good. I'm going to choose this one here, and I'm going to look at it. So remember, when it said it was x is equal to 1, all right? When x is equal to 1, y is equal to 1. So if we think here, I went over 1. Now notice very carefully, make sure you look at the axes, ladies and gentlemen. All right, if you look at the axes, you notice that the other one's going up by 2's. So here is our 1. So the blue one here, sorry about that, the blue one is our f of x. And then what I suggested you do from that is you look at the points. All right, so on here, when we did it, all right, when we took 4x squared, when I took 4 times 1, that would be 4. So if I go over 1, I should be up at 4, which I just happened to pick the right one. So again, pick a point if you have to, and that should help you. So I just randomly chose that one and I lucked out. But remember, if I'm looking at this here, if there's something in front of the x, not attached to it, remember, if it was attached to it, I'd have parentheses around it, and I don't have that. So this one here would be a vertical, because we know it's a is greater than 0, so it's going to be a vertical stretch. So they're going to give you 2 points on the test. Well, I mean, they're going to make it each half, so they'll probably give you a half a point for selecting the correct graph and 1 for giving the right stretch or shrink. Remember, if a was less than 0, it'd be a fraction on that one. Okay. On number 5, it says use a graphing calculator to graph g of x is equal to 2x plus 8 and its parent function. Then select each transformation used to translate from the graph of the parent function to the graph of g. All right, so on that one there, let's go ahead and let's see. I do believe I have a graphing calculator here. So I don't want to leave the site, but I want to put in y, or g of x, right? So we can just say y, because g of x is this fancy way of writing y, is equal to, and then we have what? 2. What's my absolute value functions here? There. Oh, it's right here. Sorry about that. Again, I'm not gonna redo it just because I couldn't find something. And then remember, in that we're gonna put x. And what does it say? What else we're gonna do? We're going to add 8. So we're gonna say plus 8. Okay. And then they want us to compare it to the parent function. So remember, our parent function on this one was y is equal to, there's my absolute value, x. All right. So as you can see, what did we do there? Okay. Well, if you look here, we went up 8, right? And then the 2 in front, I mean, I didn't really even have to graph it. I just did because that's what they told us to. Because remember, this right here is our vertical stretch or shrink, and this is our vertical translation. So it goes up or down. So remember, it's a is greater than 0, so we know it's going to be a stretch. So we're going to click on this one here, and you're going to click on that one there. All right? Oh, here, let me get rid of this and put this back up. So those are the 2 you're going to click on. Okay? Let's see, number 6. It says let f of x equal -2, x minus 7, write a function whose graph is a translation 6 units to the right of the graph of that. So left and right, I'm going to attach it to the x. Remember, when we talked about it, if it's right, we're going to say it's g of x is equal to f of x minus 6. So wherever I see x, I'm going to replace it with x minus 6. I'll have that negative 2. And then I'll have x minus 6 minus 7. So now I'm going to distribute that 2 through the parentheses. So that'll give me negative 2x plus 12. Now that I've distributed, I can drop the parentheses, minus 7. And now I'm going to simplify that, and I'll get that as negative 2x plus 5. So on this here, again, they're not asking to put g of x. Watch stuff like that very carefully, but that will be our answer. Okay? Let's see. Let f of x equal 2 times x minus 3 quantity squared. Write a function g whose graph is a reflection in the x-axis of the graph of f. So on this one here, remember our rule was g of x is equal to, since it's in the x-axis, we say negative f times x. So we're going to take and put it on the outside. So on here, I'm going to take negative. Remember, my f of x was 2 times x minus 3 quantity squared. And I'm just going to take that negative and put it on the inside, attach it to the x. I'm not putting it through the x minus 3 squared. All right? So our final answer will be this. Okay? Number 8, excuse me. Let f of x equal 5x plus 8. Write a function g whose graph is a horizontal shrink. Oh, there we go. I keep hinting whenever I hear the word horizontal, what am I going to do to the factor? I told you I'm going to flip it, and I'm going to attach it to the x. So remember, what I'm telling you is that g of x is going to be our f, and wherever I see my x, it now becomes 5x. So I have that 5 already, but now I have this 5 times x because I attached that other 5 to the x plus 8. And if I work that one out, distribute that 5, I'll get 25x plus 8. And that's what you would put. Okay? Let the graph of g be a translation 4 units down, followed by a reflection in the y-axis of the graph of f of x is equal to x. Write a rule for g. So they're telling us that our f of x is equal to x. All right? And they're telling us, again, we're doing 2 things here. We're first going to go 4 units down, and then we're going to go followed by a reflection in the y-axis. So we're doing 2 things. So remember, I told you your book likes to do, when we do 2 things, they like to do, they like to start you with h of x. So our h of x is going to be x minus 4. All right? And now our g of x is going to take our h, and wherever I see, since it's in the y-axis, I'm going to attach it to the x. All right? So on the one above, I'm attaching that negative to the x, and that's all I'm doing. So the negative 4 stays the same because it was on the inside. All right? So that's our answer for that one. Number 10. The graph of a function g is the transformation of the graph of f of x is equal to 4x minus 10. our g of x is 40% of f of x. Write a rule for g. Remember, the word of means times. So what they're saying is our g of x, we're going to take whatever it is, but we're going to take 40%. Remember, 40%. I'm going to move the decimal 2 over, so it's going to be 0.4. So g of x is going to be 0.4, and it says it's going to be 40% of f of x. So that means the whole thing there. And when I distribute that 4/10 through the parentheses, I'll get 1 6/10 x minus 4. That'll be our answer for that one. Number 11, write an equation of the line shown, then use the equation to find the value of x when y is equal to 185. So remember, when I'm talking about an equation of a line, our line is y is equal to mx plus b. All right? Remember, your m is your rise over your run. So if they give us a graph, we can kind of figure that out. So I start right there, and that's my y-intercept. On this one, I can use my y-intercept. Sometimes I can't. But if we look, I'm going to go up 10, 20, 30, and then I'm going to go over 1, 2 to get to the next point. So I just told you I went over 30, went up 30, excuse me, there's my rise, and then I went over 2, all right? So 30 divided by 2 is equal to 15. So right now, you know that y is equal to 15x plus b. But again, b is your y-intercept. And if we look here, our y-intercept is right here. So in this case here, it was easy because b is equal to 20. If not, remember, I would choose a point to get it. So right now, we know our equation is y is equal to 15x plus 20. All right. So now it's saying when y is equal to 185, what is x equal to? So I'll have 15x plus 20. So now remember, I'm going to subtract 20 on both sides. So when I move it up, because when I move this 20 over to the other side of the equal sign, it becomes negative. So I'll have 165. And then I just like to put the 15x on the other side because now I know I'm going to divide by 15. So when I divide by 15, I'm going to get 11. So our equation was y is equal to 15x plus 20. And when y is equal to 185, x is equal to 11. So there's the two answers they required of you. All right, which of the following is a line of fit for the data? All right, so on this one here, there's two ways to go about it. And you're going to kind of see which one looks best. But you can also note that it's not going to be exactly the same, but you can, based on what you can see, you can find out what the right answer is. All right, so on this one right here, I'm going to show you two ways. So again, y is equal to mx plus b. All right, so again, I told you I'm lazy. I'm going to use ones where x ends up being 1. So I'm going to use this one here. And I'm going to use this one here. Okay, so if I use those, you'll find out that I'm going to get m is equal to y2 minus y1 over x2 minus x1. In this case, I get 7 minus 3 on the top. I get 3 minus 2 on the bottom. 3 minus 2. And I get 4. All right, so if you notice over here, I don't have a 4. So, but it is positive. There's the key. It is positive. So if I look at that, that should help. Just remember, it's positive. Okay? So if it's positive, we know that we can actually get rid of the bottom 2. All right? So let's go ahead and keep going. So again, remember, I'm going to choose one of the 2 points again now. So I'm going to choose, for some reason I chose this one. Okay? So I'm going to plug in 7 is equal to, well, we just said our m was 4. And then we have 3 plus b. So I'll have 7 is equal to 12 plus b. And again, on this one here, and this is one of the reasons why a line of best fit is at best a good approximation. But if I subtract the 12, I'll get that b is equal to negative 5. So on the one I just did, I get y is equal to 4x minus 5. All right, well, it's still not perfect, ladies and gentlemen, but again, look at right here. Okay, which one is negative? Well, it's going to be this one right here. All right, so now I'm going to also show you, because it'll set it up for our next problem, I believe. Yeah, sets it up for our next problem. So let's go ahead and use our graphing calculator. All right, so I'm going to do the same thing, right? Except now I'm going to get rid of that. I'm going to get rid of that. And remember, I'm going to do this table. So I'm going to go to add an item. I'm going to do my table. And on my table, I'm going to put in 2. And then I'm going to put in 7, 4, 9, and 3. I'm going to go back up, and I'm going to put in 3, 21, 12, 27, and 7. All right, so mine was already zoom fitted, I guess. Remember, this little plus sign here will make it so that you can see it a little better. I think when I did it, well, there, I just zoom fitted again, so it's pretty good. So remember, on the second one here now, what you want to do is you want to do y. And then remember, you need to do the sub to get it to work. So if I do the sub, I'm going to go right here at A, and then the B's the sub. And then I'm going to put in 1. And remember, now you have to either tab over or get it so that your cursor comes back up. And then you're going to use this regression right here. And then you're going to tell me m. And then you're going to tell me times x. So I'm going to do x. And I'm going to, again, I have to do this sub, and I have to do a 1. All right. And then tab it over so it comes up again, and do plus, and then b. All right. So now notice on this one here, what it did is it gave us this 3.38. So if you think about it, it would be 3.4. And then our b is negative. Well, it'd be negative 3 if I did it to the whole number, or negative 2.9. So again, it's not perfect, but if you look, we have a couple of outliers there. So either way, we kind of got the same thing, right? The m was positive and the y-intercept was negative. So kind of look at that on this problem, okay? All right, now remember what I told you earlier is that we can do the next problem. So let me go and tell you. So I was still there, so let's look at the next problem. Oops, sorry. It says use the linear regression feature of a graphing calculator to find an equation of the line of best fit for the data. Round each value in your data to the nearest tenth. in your equation. All right, so again, I'm going to do the same thing here. Now remember, I told you this is what's nice and is on here. Now I can just go ahead and just leave these, and I can leave the mx plus b. So I'm going to put in a 1, 2, quit looking at the thing because it's not going to do us any good until we're done. And then I'm going to have 10, 15, 28, 40, and 59. All right, so again, it's kind of looking there. Good. All right, if I zoom in a little better, it shows us a little better. And again, look at what we have here. And I did write it down. Right, so our M is 4.39409 and our B is 5.7931. So back to this here, I just told you our M was equal to 4.39409. And they said to the nearest tenth. So remember, the nearest tenth is the first one after the decimal place. So I look at the hundredths here. It's a 9, so it's greater than 5. So I know I'm going to move that up. So I'll have 4.4. And they are pretty strict on this. I have seen them take it again. I'll give you partial credit, but I did notice last semester actually, that they were pretty. If they said to the nearest tenth and you did it to the nearest whole number, they marked it wrong. So our B here was 5.7931. Again, that's the tenth. So we are going to say that is 5.8. So our equation then would be the line of best fit would be y equals, I already got that for you, so you're just going to put in 4.4x plus 5.8. Okay? So the table here shows the distance y in miles that you are from a city after x minutes. What type of function best models the data? So again, you could put it in, ladies and gentlemen, but kind of look at what we're doing. We are going from 45, so I'm going to make a quick thing here. So we're going from 0 to 45. Then we're having that to 20, 40, 60, 80. So then at 20, we're going to go to 22.5, which is half of that. At 40, it's at 0. At 60, it's 22.5, so we're going to have the same thing there. And then at 80, it's at 45 again. So if you kind of look at that there, and if I connected the dots, okay, and since it's kind of linear in shape on one of them, it has to be the only thing this one could be is the absolute value function. All right. If it was an x squared function, these ones right here would probably be quite different, right? Because you'd be squaring it. On this here, we kind of just went in by half. All right. So that one has to be an absolute value function. Number 15, and our last one here says 2 rental car companies charge an initial fee plus a fee per day. The table shows the total cost of renting a car for X days from discount rentals. The total cost Y in dollars of renting a car for X days from Payless Rentals is represented by the equation Y is equal to 55X plus 60. Which rental company charges less per day? Less per day. So just think that is going to be dollars per day. That's a ratio. So that right there is going to be your M, right? So remember that. That'll help you a lot. So let's go ahead and call this one X1, Y1. And this one here, X2, Y2. And we have to find the equation of our line for this one. We already have it for the other one. So on this one here, we're going to say Y is equal to, well, first of all, let me first tell you what our slope is. So I'm going to say m is equal to y2 minus y1 over x2 minus x1, which again would be 265 minus 185 over 4 minus 2. So 265 minus 185 is 80, and divided by 2, because 4 minus 2 is 2, that will give us 40. So now our equation is y is equal to 40x plus b. So now we have to find out what our b is. So I took the first one there, so I can say that 185 is equal to 40 times 2 plus b. So 185 is equal to 80 plus b. All right. And, well, that's 185, excuse me. Okay. So if I subtract the 80, I'll get that b is equal to 105. Now, I know a lot of you are saying, why am I still doing that? I don't need that. And I'll say, well, yeah, you do, because you need it for the second part of the equation. So here, I'll call this one DC for you. And DC is y is equal to 40x plus 105. Okay. Oops. Okay. Sometimes I hit the wrong thing. And then let's see, the other one was Payless, so let me just call it PL. And on that one there, we have y is equal to 55x plus 60. Okay, so now I just told you, since it says charges less per day, that's money over, so that gives us our slope. So you're going to compare the two slopes here. And as you can see, DC it's 40. For Payless, it's 55. So the only answer it can be is right there. Okay. Make sure you think of how it is. Okay. So it's money over day. Again, that's our y over our x, which is our slope. And then it says, and so on this one here, I forgot to do it. So yay, we're going to figure this out. It says the total costs are the same after how many days? So again, when they are the same, that means when they are equal. So we are going to say that 55x plus 60 is equal to 40x plus 105. Okay, so now I have to solve that for x. So I'm going to subtract that 40x because I'm moving it over to the other side of the equation. So 55x minus 40x will give us 15x. And I'm going to take that 60 and I'm going to move it over to the other side. So it's going to become negative 105 minus 60 would be 45. And now I'm going to divide by 15. When I divide by 15, I'll get that x is equal to 3. So the total costs are the same after 3 days. Hopefully that'll help you. Remember, the test is going to be very similar. Probably the numbers are going to change. All right, good luck. And I'll see everybody tomorrow. Now remember, this should go in as an assignment. So I should have a copy of your percentage that you got on this. So you do still get 10 points for this. Thank you. Have a nice day, people.